Hello, and welcome to today's webinar, AS Interface, Applications and Financial Advantages, brought to you by AS Interface. I'm John Appleson, and I will be today's moderator. We have just a few short announcements before we begin. Discussing today's topic from AS Interface will be Yen Lee, Product Manager for Networking, Safety, and RFID Products for IFM Effector. Yen has been employed with IFM Effector for 16 years. During this time, he has gained extensive experience in how controls are used to produce finished products in many industries throughout the U.S. As Industry 4.0 is evolving, Yen has focused on educating industry leaders on the current trends in automation and how OSI plays a key role in increasing efficiency and improving production systems. During the Q&A session, Yen will be joined by Kartik Vashi, Application Product Manager for Schmersel, and Dr. Helga Hornis, Technology Director with Pepperl & Fuchs. Please ask questions at any time during the presentation by typing in the Q&A panel. Enter questions as they come to mind, and our speakers will address them during the Q&A session or by email after the webinar. I will now hand the presentation over to Yen.
All right, thank you, John. All right, thank you for everyone for attending the webinar here today. I have the great pleasure to introduce the topic today, OSI applications and some of the financial benefits that you would see from applying OSI. Before I get into the details of some of the applications and some of the financial benefits with ASI, I kind of want just to take a little time to kind of review, what is OSI today and where does OSI stand in the whole entire market today. So today, the OSI interface, there's 36 million nodes installed in the field. There's many members worldwide that supports this particular product, up to 350 worldwide members. So it's definitely a product system that is been well developed, well supported worldwide. In fact, there's quite a lot of different products out there, and for those of you guys that are interested or are using OSI today, you know there are many people who do support the product today and offer system components to it. And you see with this graph here, the technology is by far still growing quite rapidly. And in fact, by 2025, we expect to have the numbers of nodes installed to up to 60 million. So that nearly will be double what we expect today. So the technology itself is constantly growing, constantly evolving, along with the automation trends of today. So what is OSI? Again, from previous webinars you might have attended, OSI is the simplest networking solution that's available in the market. It's designed to take bit-level devices, on-off devices, and interface it with the upper-level networks such as Ethernet IP and Profinet, or even directly to PLCs. And one of the big things with the OSI system, it is not a proprietary technology. It's an open platform, and again, supported by many vendors worldwide. And one of the major advantages of the OSI system is the ability to reduce project costs with a significant percentage, really due to the simplification of the design, reduction in wiring, and reduction of commissioning time. Okay? And that's really the big part of it. When you get down to the heart of the OSI system, when you take out all the hardware components on there, the really big benefit for the end users, for the customers, is the fact that for the overall machine cost, the OSI system really does reduce a lot of the, let's say, the soft cost of the system. And for me, the best way to show these cost reduction and wiring savings is really through pictures. So here you have an application where you can see a before and after picture. So you see a before picture of a system that was installed with all hardwiring system, with all input cards and output cards attached, and an after picture system of what happens when they took all this, retrofitted the system with the OSI system, using the same control cabinet that you see today. So you can see here the dramatic before and after picture of all the reduction wiring here. And that's why we really tout that OSI is one of the simplest networking structures out there, because we're able to reduce so much of the complications when compared to traditional hardwiring, and even comparing itself to other traditional field bus systems. Here's another picture here that illustrates the same point. Here you can see a control cabinet that's wired with some safety components with hard wiring to terminal strips. And here's an after picture of seeing the reduction of being able to simplify the system through the OSI wiring. And you see the dramatic reduction of potential cabinet space and all the hard terminations that would be required if you were hardwiring the system in this way. Okay. Again, at the heart of the system is really the two-wire flat cable system. Okay. And this really allows the system to take all those bundles of wires and really reduce it to a few two-wire flat cables that runs out of your main cabinet. And here's an example here of being able to take all those bundles of wires and really reduce it to a two-wire flat cable system. So with that being said, with all the benefits we're talking about, what are the out of all these factors, what are the factors that really affect the cost of the machine? When you look at machine cost, it's not always just about hardware. It's not you don't always compare hardware apples to apples, right? It's really a lot of the cost around it. So when you look at a machine cost or you look at a project cost, you really have to factor in the engineering time that's involved with installing the controls architecture, the installation time in terms of being able to pull wires, label, terminate, right? Being able to commission the system once you get it on site, how easy it is to reinstall all the wiring and get it up and running again. Of course, every machine requires some changes typically as well. So how easy it is for you to change the system, rewire everything, relabel everything, re-terminate everything. How do you break the machine down if you do need to break the machine down and ship it out? And then how to do this repeatedly with every job that you have. Those are all the different costs that goes into building a machine and making the machine cost effective and making your machine competitive in the market. Okay? And with the OSI solution, OSI addresses a lot of these bucket areas to help reduce cost of the machine, to help reduce the overall ownership of the machine. When you look at engineering, instead of having a bunch of circuits and wiring schematics, you really only have two wires you have to deal with in terms of the system. Installing it is just as easy because now you're only dealing with two wire cable bundles here instead of a bunch of individual terminals that need to be routed back to junction boxes and main panels here. Okay? Commissioning. Again, commissioning and installing really goes together a lot of times where you have only, again, the two-wire system being able to be used here. Okay? And those of you who have used OSI in the past before, you know that with a flat cable system, being able to modify, be able to change and move components around easily is a big part of what makes the OSI system very, very cost effective. Okay? And with some of the applications we'll show later on today, shipping, larger machinery, large conveying sections, being able to break them down easily, ship it out, and then reinstall it on site very quickly is a big part of what you can do to cut costs in machinery. And again, startup. How many man hours do you have there? How many people do you really need to start the machinery? These are all things that affect the cost of a machine. And when you look into more the details, and you go look into the details of each of these buckets here, you have design and engineering. Okay? Again, the OSI system here impacts this bucket here by being able to simplify the documentation, by only having to think about the two-wire cables, two terminals there, and the modules that simply are almost like Lego pieces where you can snap onto the yellow cable. Really does simplify the documentation because no longer you have to worry about one terminal going into another sheet of your documentation, which means also if you have changes to be made, there's less documentation that you need to think about in terms of those changes. Okay? Being able to design the OSI system for all your different platform needs. It's nice to be able to standardize on one PLC platform, but unfortunately, the market doesn't always allow us to do that, where you might have to design a system for a Siemens PLC, for a Allen Bradley PLC. It'd be nice not to have to re-engineer, redesign your system every time there's a controls architecture change or a field bus change. OSI allows you to design your I/O system the same way, every way, without having to dramatically redesign your controls architecture every time there's a new PLC involved. Labor is a big part of the cost factor when you're looking at the OSI impact. Again, simplified wiring with installation displacement technology. Again, nice thing about it is being able to snap I/O onto the flat cable like Lego pieces, and be able to remove them and modify that easily to move the I/O modules to different locations just as easily without having to, unwire and rewire, re-pull wire to different locations. Okay? Being able to run just a 2-wire flat cable from the main control cabinet instead of big wiring bundles or big harnesses that would be required if you're doing everything through hardwired, and being able to use standard patch cables for all your I/O connections instead of having to run everything through terminal strips. Those are all things that will impact the labor of the machine. And a lot of times, I consider labor and commissioning the same thing in many cases. Commissioning involves all the different labors that you'll have to do. You've done all the hard work, but now you're on site trying to get everything up and running. Again, the same advantages that you see in labor are the same advantages that you see in the commissioning of the machine. Materials and hardware, right? If you try to compare, an OSI block to another block, it's not always apples to apples comparison here. What you have to look at is that, okay, if I'm able to move the I/O outside of a junction box, what am I able to do? So in the previous pictures that you see, with the OSI system, you can actually make your main PLC control cabinet a lot smaller. By making it smaller, you have more space to do other things, and you reduce the cost of the enclosure. Okay? You're able to eliminate J boxes. Okay? If you can put everything out in the environment, then you can remove all the J boxes and all the wiring that's required for that. So in that way, you're really saving on materials and hardware for your total system. And the last thing is really design changes. Okay, the ability to be able to make changes quickly on the fly without first changing a lot of your documentation. Being able to physically move the I/O blocks to the correct locations and a new location where that is. Those are big things that can save cost on the machinery. Okay. So, saying all that, I want to move into now the little bit of the applications. So the OSI applications are in just about any industrial situation that you can imagine. There's OSI in material handling and robotics, food and beverage, assembly automation, test systems. I mean, you can even find them at roller coasters, amusement park. It's really any industrial machine can use the OSI interface bus. But it'll take too much time for us to go over all the different applications here. So what I would like to do for this particular webinar here is to really focus on a few of these applications from our customer base and kind of review the return on investment that was achieved by using the ASI system in this case. So one of the largest industries for ASI is really in the material handling world. In that world, the I/O is pretty spread apart. It's not in dense structures, which really suits itself to the OSI interface system. And one of the biggest goals here for this industry is to reduce project timelines, especially when you're designing large warehouses, miles and miles conveyors. You really have to figure out a good, efficient way to meet timelines and to be able to cut those timelines down. Again, with every OEM, with every project that you're dealing with timeline time frame is always the biggest critical portion of your job. It's trying to figure out how do I install and design a system in a quick way that allows me to get everything done on time at the correct cost level. So from my experience with the material handling world, by going with the OSI system, the main goal for them is really to reduce this time. And in many cases, you can reach the up to a 50% commissioning time rate of being able to reduce that. And this all comes from the whole entire, again, life cycle of this. So when you get a project, you design the machine. You have a certain amount of time to design a machine. In the conveying world, you really have modular conveyors. So each conveyor has a certain amount of I/O. Being able to modularize that with certain I/O points and being able to design the conveying system quickly is a big portion of it. So imagine if I had several miles of conveyors and I have 2 meters worth of conveying sections. I know automatically in my design specification how many conveyor sections I need to order, and from that how many I/O modules I need and how much cable I need. And being able to route the OSI cable and attach the cables together very quickly in this modular design really saves in the commissioning time and the design and project time of these types of systems. Not to mention, when we mentioned that OSI is one of the simplest systems to install, it's also one of the simplest systems to also help maintenance. Okay, so maintaining a system, troubleshooting a system, it's also quite easy because the system is not trying to do a lot. OSI is not trying to do a lot other than bring I/O to your system and interface it with your controls architecture. And because of that, there's a lot of diagnostics, a lot of ease of diagnostic, a lot of ease of installation that the maintenance people can be trained on to better understand how to troubleshoot the system. Okay. So another good application that fits OSI is the pallet and depalletizing machineries. Right? One of the main goals, again, here for these guys is to be able to be competitive in the market. And be able to be competitive in the market requires on-time delivery and on-time commissioning. Many of these cases, when you commission a pallet or depalletize a machine, you maybe have a whole entire weekend to maybe get it up and running. Okay? And if you only have a weekend, now you need more manpower to be able to install the system on time and get it up and running. Okay? So one of the first goals with some of these specific customers is first to reduce the wiring and reduce the cost of the machinery in that way. So in this particular case, this customer, usually with the traditional wiring that they had before, it would take them 1 week to commission everything, rewire everything because they have to break the machine down, put it back up together. But now, using an OSI system, they're able to do this commissioning in 1 or 2 days, which fits within the schedule and a promised delivery to the customers. Be able to reduce the total commissioning time from 2 weeks to 1 week on the machine, meaning runoffs and everything like that. Again, being able to meet the customer's time frame. If we're able to commission these machines quicker, that means we can get more projects and more machines built and out the door quicker as well. So one of the big aspects of this is being able to reduce manpower. Typically, it would have taken 3 people on site to be able to do all the work. Now they can only send 1 person on site to be able to do the majority of the commissioning and the runoff when these systems are delivered. And a lot of these are the big benefits. And the side benefits outside of being able to meet on time and produce these machines at a better rate is the ability to also reduce all the cabinets they had before. In this example here, the before picture was a lot of hard wiring and 2 large cabinets in order to fit all the components in. That took up a lot of space. That was cost. Aesthetically, it wasn't as pleasing on these type of machinery. But by going with the OSI system, they were able to reduce that cabinet from 2 large cabinets to 1 single cabinet now, which again reduces the hardware cost overall in the machinery and also makes the aesthetics of the machine a lot better as well. In the packaging world, right, Again, another great application for OSSI. And in this case, it's probably, I would say, better suited even for the OSSI safe system in this case. So in this example here, one of the largest goals on these machinery was to reduce and simplify the safety wiring. Safety wiring is generally one of the biggest pains in terms of building the machinery. There are a lot of door switches, a lot of zone controls, typically with machineries, and that was really the biggest cost and biggest time it would take to build these machines, not just for the I/O portion itself, but really for the safety portion. Okay? By going with the OSSI and the safety of work system as a total package, they were able to reduce the commissioning time by up to 30%. With this, which is a big goal for them to be able to get these machines out the door and fulfill the orders that were required. And why is that? Why was safety here such a big factor? Going into this was their typical controls architecture for safety. And as most of you know, when you're dealing with safety components, there are a lot more wiring involved. In many cases, you're probably doing 3 times the amount of wiring than you would do with traditional I/O. In this case, it's all going back to a safety relay. That's a couple sets of terminations there. This is wired to contactors to control the zoning of the machinery. And then you had another separate set of wires for each of your switches connected back to the PLC for feedback indication. And that really increases the amount of labor, increases the amount of complications that it would take, and commissioning for the system. And if you had to make some changes to the safety circuit, well, that's another issue altogether. So by going with the safety at work system in these cases, you can already say that you can save 30% of your wiring right there, because you eliminate completely the feedback wiring that's required for each of these safety components. So by itself, by just going with this technology, you're able now to just off the bat reduce 30% of your wiring, which is great. Okay? Now the OSSI safe system allows itself to attach the switches directly to I/O safety modules, or directly to the safety cable itself. And the nice thing about it, anything that can host an OSSI master to it becomes a safe system. So you don't have to go necessarily into a safety PLC situation and the safety software that would be required, because as we all know, that is another increase in cost of hardware and increase in cost in terms of software licenses involved. And with the safety at work system, it's a very simple drag and drop software that allows us to configure the system very simply, and there's not a large learning curve with it. Yeah. And in some of the studies that we've done as a group, when we look at the cost analysis of the safety at work system and being able to install OSSI to it as well, you can see with a small system with a couple I/O points or a couple safety points to it, you see in the conventional system here, of course, your component cost is a large portion of your cost, and the installation of machinery is about 20% of that. By going with the OSSI system, of course, again, if you're comparing it to traditional wiring, your component cost is always going to increase a little bit, just because we're selling more intelligent equipment there. But really, the big benefit for you is seeing the installation cost go down dramatically. And in this case, in a small machine, we're estimating anywhere between 5% in total cost of the system. So here, again, kind of what we've been always touting is that really, if you just look at the hardware cost of the OSSI system, it's not a fair comparison. What you really see is really the installation and labor and commissioning cost savings by applying the system, which really will dramatically reduce cost here. Here, if we look at a larger system, again, the comparison would be the parts and then installation. It's the same trend here. Of course, the parts would be a little bit more expensive, but really where you have the biggest saving, and you have a bigger saving when you look at larger machinery, It's really the installation time and the commissioning time here. Okay. Another huge application for the OSI system comes into the valve clusters. This is a valve cluster that you see here, typically that you see in the food and beverage environment with rising stem valves. And really, simply said, there's no really better solution on the market for such applications. I mean, you can hardwire these valves, and you'll have a big wiring mess involved. You can go to Ethernet or DeviceNet or some kind of field bus directly there, but it's not as nearly as cost effective. And if you go to Ethernet for each of these valve clusters, you'll have a tough time managing all the Ethernet IP addresses that are required on the system. And then you have another issue in terms of being able to manage bandwidth and collision on the network there. So ideally, it just doesn't make a lot of sense in terms of these applications. But bringing this to the OSI system makes a lot of sense because you have a lot of these heads. You can buy the OSI head from many numerous vendors, and you can install up to 124 of these devices over one single Ethernet IP address, which means now you have less. You're fully utilizing the Ethernet bandwidth, and you're wisely spending your IP address in your plant, and that's really a big selling point when we get into these applications here. Again, we can take this not in just rising stem valves. The same benefits goes towards the same type of valve cluster, but in quarter turn valves. Again, all the same benefits with that, being able to bring 124 of these devices into one Ethernet address. So that's another great application that's typically used for ASI. And we did do a little cost study in terms of these valve clusters when we compare, conventional valve head wiring to maybe another bus system like DeviceNet, and then comparing that to the OSI bus. Okay, so when you look at the actual valve head itself, it's pretty comparable in cost in terms of the conventional heads. Right? A little bit more expensive, but not nearly as expensive as maybe an Ethernet IP head or a DeviceNet head. But outside of the hard costs, again, really what you're saving is really all the installation labor cost that's involved here, because it's a lot simpler to run the two-wire flat cable to these types of valves than to run a DeviceNet cable or big wiring bundles here. Here's another example, because sometimes we think about the ASI system as just being a machine installation, and far from it. We've done many applications that are at a plant-wide installation, and in this case here, we were looking at a tank farm application here, where we are actually bringing discrete on-off signals to OSI. We're bringing analog to it. We're bringing the valve clusters to it, all into one large project to integrate all those signals in. And again, if you've attended some of the previous webinars here, it's a myth that analog is not a good fit for the ASI system. Analog is absolutely a good fit for ASI system, as long as it's not something that's time dependent or like a big motion control. Right? If you're not looking for high speed reaction of 10 milliseconds or less, typically the OSI signal for analog is more than sufficient for a lot of these applications here. And you see here, we're able to take all the different varying components of what we can integrate into the OSI system and bring it all over to the upper level network. In this case, it was Profibus DP. Okay? And then again, the main reason why this was chosen in this case was the fact that they had a very short commissioning time to be able to get this thing up and running. They had to meet cost. They had analog signals, and traditionally an OSI analog input is less expensive than traditional analog card inputs per point. Not to mention, this can take it outside the environment where we can get rid of the junction boxes here and be able to wire everything very quickly here during startup. Okay. So another good fit that some of the vendors offer here are the ability to be able to use OSI in sanitary environments. Again, one of the larger markets for ASI is in the food and beverage, where we can integrate a lot of the components. And in this case, there are vendors here that allow to have IP69K type of environments, where we can take everything outside of the junction box, which again saves cost, and not to mention it allows us to easily expand the system if necessary. So typically people would save some I/O points as spares. So anytime they need to add a new valve to the system or add a new sensor or instrument that needs to be added to the system, now it's very easy to add that in instead of having to pull wire through conduit into this environment here. Okay. Another unique applications that you can see OSI on, and really you don't really think about this, is some of the harbor crane applications. You see a lot of these harbor cranes that are out near the bridges, bringing our packages overseas through these spreaders, which are basically these large arms that come and grip these containers and move them to the storage locations. OSI is actually a very big component to a lot of these manufacturers because it lends itself to be able to be very robust against these outdoor environments, EMC conditions. The big benefit too is being able to just run a single 2-wire cable up to the control arm of the spreader to bring all the I/O back to the system. And with that, those are the really big benefits of why this specific industry chooses OSI as one of the bigger components for wiring. Okay. And here's another unique application that you would see too, is automated silos. Automated silos, you wouldn't think about having a lot of automation there, but you'd be surprised at how much automation is actually in this to control the divert tubes and everything for the grains. And not only is the electrical wiring concerned, but it's also the pneumatics. So typically, you would have large amounts of pneumatics being wired over here to control all the valves here. And that will tend to also be just as complicated as the electrical wiring in this case. Okay? And this picture is kind of hard to show you the simplification here, but in the next picture here, this is actually a conveyor section here. This kind of gives you a better look at the simplicity of how you can actually reduce the electrical wiring through ASI and also the pneumatic wiring here. So when you look here, you see the green box here. That's the pneumatic tubing being as one large run, straight run, and then tapping off to each of these air box pneumatics that controls the diverts. Along with that, there's I/O that you can also bring into the block as well to get your feedback on your application here. And you see here is the yellow cable and the electrical run that's being run. So you can see how this could very well simplify your installation, especially if your pneumatics are distributed in the way like the silo is in this particular, and also in this specific application, the conveying section. So just to conclude here is that I want to just summarize through the applications through kind of summaries that that you can see that from all the different buckets that we have with the ASI system and all the different buckets that affects the cost of the machinery, that OSI does address a lot of these different buckets. And that's the reason why a lot of people do choose OSI as one of the field buses to use on these systems. You can see from the design and engineering aspect that we can save cost there. We can save cost in terms of labor and commissioning of the system. We can save cost in materials and hardware. Sure, there's an increase in cost in terms of the I/O points, but what it reduces is a larger saving compared to the actual increase in terms of the actual OSI hardware itself. And the big benefit is being able to make changes rapidly and without having to change your documentation. Those are big things that can take up a lot of time in terms of the project here. So, there goes that slide there. All right. So that summarizes everything here I wanted to kind of talk to everyone about here. For me, I wanted to talk about what we're offering as well. I mean, if you're interested, we have a hands-on technology workshop coming up in October, where you'll have a live setup demo where you actually work with the Aussie system itself, integrate everything into the system. It's a live workshop with all the panelists of experts that kind of go through all the different aspects of Aussie, including safety work, all the diagnostics. You'll get to set up a system live yourself during this workshop. And that workshop is going to be held in Cincinnati, Ohio on October 24th. And those of you who have joined this workshop here, you will get an email with a link to register if you'd like to come out. Everything's totally free, so please come out. Lunch is on us, and we can kind of go through what we've talked about today in terms of the Aussie system and all the different benefits. Okay, so thank you for your attention, and then we'll move into the Q&A section, and I'll bring it back to you, John.
All right, thank you, Yen, for that enlightening presentation. We'll now move into the Q&A section of the presentation. If you have a question, please submit it now by typing in the Q&A panel and click Submit. If we do not have an opportunity to get to your question, we'll answer it afterwards by email. Okay, so we have a couple of questions here. The first one, our US-based customers know very little about AS Interface when it comes to applications that have been solved in the real world. We'd like to use AS Interface but face resistance. What events, tools, or resources are available to educate our customers?
Okay, John, this is Helga. If it's okay, I'd like to take that one. A few of the tools out there they were already mentioned by Jan. We have a technical hands-on workshop. There's one coming up. We typically hold 3 or 4 of those in a given year. The association has a website that's a good resource. Also, as a group of AS Interface providers, we participate in trade shows. So we just came back from PAC Expo. I understand that's too late, but next year there's going to be another PAC Expo. The member companies provide instructional videos that can be viewed on YouTube. Also, the member companies provide various printed materials from catalogs to how-tos and troubleshooting guides, application notes. So there's a large subset of information available. Also, I should mention that maybe they can take you along and show you existing installations. So specifically, one member company is setting up a warehouse and logistics center in the US right now, and it utilizes quite a bit of AS Interface. So whoever would like to see that can see AS Interface in operation in the real world, in a real system that needs to make money every day.
All right, well, thank you, Helga. We have another question. If I'm doing a safety upgrade on an existing machine, and if I adapt Aussie for safety, how can I wire in an existing emergency stop and reset button?
Hi, this is Kartik. I'll take that one. Yeah, it's a good question because many people are doing integration or upgrading their machine. At that time, if they're thinking of using Aussie, the AS interface for safety, it is a great idea, and it's simply the existing emergency stop or reset button can be wired to a safety or non-safety I/O card or the I/O module. The I/O module actually can be an IP20 rated, and it can reside in your in the electrical panel, or if the existing e-stop or reset button is a quick connect type, then also there are modules that are available with IP67 quick connect field attachable modules, that field attachable I/O modules. So it is definitely possible to expand your system with Aussie when you're using non-conventional or sorry, non-ASI components, and if you're using conventional components.
All right, thank you, Kartik.
Yeah.
Another question, how does ASI support other field buses such as Profinet, EtherCAT, and CC-Link?
Hey, John, this is Yen Lee again. I'll take that question. So that's really the beauty of the ASI system, right? The fact that as a machine builder, you can standardize on your I/O platform, no matter if the customer specifies a Siemens PLC, an Allen Bradley PLC, or even a Beckhoff PLC. You know, by doing this, you wouldn't have to redesign your controls architecture, every time, and this would save in your design and the engineering time. All it would take is for you to change from one field bus to another is to really choose a different ASI gateway. And all that ASI gateway does is translate all the ASI information and bring it into the correct data mapping for the field bus of your choice. And from there, it's just data at that point in time for your PLC to work with. It's really that simple.
All right, thank you. We've got time for a couple more here. AS Interface is being seen as a German solution closely tied to Siemens. We are using mostly Rockwell PLCs. Isn't it natural to use Ethernet IP rather than AS Interface?
Okay, John, if I may take that one.
Please.
It is certainly true that AS Interface is a significant player in Germany especially. It is, after all, a solution that got kick-started out of Europe many years ago. But nevertheless, one of the reasons also is that Germany is still a very big player when it comes to automation. So I think it's a natural fit for AS Interface to be strong there. Yen did mention though that ASI is really exceptionally well suited to play along with Ethernet IP. So I don't like necessarily to make it a competition between Ethernet IP or ASI. It is ASI brings the simplicity to Ethernet IP, and if I had to boil it down to really two terms, Ethernet IP is a throughput based, whereas AS Interface is very clearly advantageous in terms of simplicity. So use them together for the best benefit.
All right. We've got time for one last question. Can I do safe, zero speed, or standstill monitoring on ASI? Also, is safe speed monitoring possible for setup with limited speed function? Who'd like to take that?
Yeah, this is Kartik. I'll take that. Thanks, actually. Yes, of course, it's possible to do zero speed as well as speed monitoring and many other speed monitoring functions via speed monitoring modules that are available from various companies that offer AS Interface products, and the zero speed and or speed monitoring is done via encoder input to the ASI speed monitoring modules, and the speed levels can be set up with the Ozimon software. So it becomes a very simple solution if you wanted to add speed monitoring, such as safe limited speed or safe limited increment, or those type of functions that are needed for jogging of the machine or setting up of the machine. So yes, it is possible.
All right. Well, thank you, Yen, Kartik, and Helga for providing us with so much information. And thank you also to our audience for your questions and to attending today's event. This presentation will be available shortly in an on-demand format. So as an attendee, you'll receive an email with detailed information on how you can access the on-demand replay of the webinar. Please feel free to invite your colleagues who do not have an opportunity to attend today's event. The presentation materials are owned and copyrighted by AS Interface, and the individual speaker is solely responsible for his content and opinions. Well, thank you for joining us, and have a great rest of your day.